Hey guys, so we're gonna get started here. So today is Tuesday the 27th. It's a B day. Today is day 6 of the second quarter. So we've got some things to do today. Today's kind of our busy day for the week. We're only gonna see each other today and Thursday. So the stuff that I'm assigning today, most of it will be due during class, but it's a lot of kind of quick things. And then we're gonna have some classwork that will be due by the end of the week. Okay, and I'm gonna try to keep that format. We're gonna have a couple things that we'll do each day, and then we'll have some kind of classwork that you can kind of work on over a couple of days. Okay, so we're gonna have a warm up today. The warm up will be a Google form. So let me see if I can open that and see what that looks like. So here's our Google form, day 6. So first and last name. And then this is a thinking question. So any answer is fine. Just put something, okay? That just means that I want you thinking about it. Then here's another thinking question. And then these, try to see if you can get these right, because I'll check. And I'm kind of interested to see what you guys know. And these questions are over everything we've talked about so far in atomic structure. All right, we did all this stuff on last Thursday or last Friday. Okay, and then we're going to take notes today over isotopes and average atomic mass. So what are isotopes and how do we calculate average atomic mass? We're going to have you guys do the ed puzzle. I'm going to make it quite short. There's not much in this part. It is a little bit more challenging than some of the stuff we've been doing. So it's shorter, but it's a little bit more challenging. And then I want you guys to take the practice quiz again. So I'll give you the link for that in the chat. And the goal here is to take the quiz again and do better than you did last time. Okay? And then I'm going to go ahead and assign the classwork. So let's look at the quiz real quick. So if I click on that link, this is what pops up. Oh, that's not the right link. Okay, I'll have to work on that link. But when you open it, it's going to ask for your name. Please put your first and last name there so that I can give you credit for taking the quiz. It's a participation grade. So if you take the quiz, you're fine. But the goal is, and what I would like to see is I would like to see students doing better on these attempts. Okay, so please don't just guess. Actually try, use your notes, use your resources, use your periodic table, things like that. Okay, and then let's look at the classwork. This classwork's pretty cool. It's pretty short. These links are very slow. Okay, so when I click on that link, this is what pulls up. It says click here to get started. This is due Friday. And for you guys, even if I got it by next Tuesday, I'd be okay with that. Okay, so I'm going to give you guys this week and maybe up till next Tuesday for full credit. Okay, and it's not bad. So you click on it. It's a Google sheet. So you put your name here. So I can type that. So you'll make a copy, and then you will type your name there. Class period. Let's say today is 1B. Whatever class period you're in. I got 1B. I got 3B, and I got 4B. So whichever class period you're in. And then we're going to type our answers in here. Okay. So here's a table that we're going to fill out. This is the element name. So some of these are filled out. Some of these are not. And so the ones that are filled in, they're done. You don't need to do them. You're going to fill in the blank spots here. So let's look at carbon. Carbon is on my periodic table. And here's my periodic table here. Carbon is element number 6. The number above the symbol is the atomic number. So element number 6. So I'm going to put 6 there. I'm going to hit enter. And the square will turn green when you get it correct. So that's really cool. So when you turn this in, I'm just going to kind of check and see if you got a lot of green squares or not and see whether you did well. So if you didn't, if you get most of these wrong, I mean, you still tried it maybe. So maybe I'll give you a 60 or a 70. But if you get them all green, then I can give you 100. Okay. How many protons does carbon have? Well, its atomic number is 6, and that's equal to the number of protons. So I'm going to put 6. I'm going to hit enter, and it turns green. Number of neutrons. Okay. The mass number is 12. So we need to take 12 minus 6. So remember, the number of neutrons is equal to the mass number minus the atomic number. So my mass number is 12. It says it right there. and I'm going to subtract 6. And I get 6. The number of neutrons is often the same as the number of protons and electrons, but it doesn't have to be. So don't assume that. You need to calculate it, okay? And so that's going to be 6. 6 neutrons. So my nucleus in this carbon atom has 6 protons and 6 neutrons. And we're assuming a neutral element here. So if there's no charge, how many electrons do we have? Well, we have 6 protons, which are positive. So let's write it this way. The total positive plus the total negative will add up to equal 0. So if I have 6 protons, that's a positive 6 charge. How many electrons do I need to balance that? I need 6, right? If I have a positive 6 and I add it to a negative 6, don't those cancel out and make 0? All right, 6 minus 6 is 0. And so I have to have 6 electrons for this to balance out. So let's put 6 there. And look, everything turns green. Okay, the second one, the element name is missing, but we have the atomic number here. So this is going to be like a puzzle, and you really got to get creative on solving these. And I hope that y'all have fun doing these as much as possible. I know some of you guys don't like chemistry, and there's nothing I could do, to make you like chemistry, but I'm excited about it, and I love teaching it, and I love when students are getting it. And I wish our class was more interactive. I know it's been kind of boring. That's just kind of how things are right now with doing virtual and face-to-face at the same time. But I hope that it's easy, and I hope that you guys enjoy being able to chill. All my face-to-face students, they spend a lot of time in class just chilling. And I don't mind that at all, because everybody has everybody has their bad days and they need time to chill, and everybody's got a million things going on. So I don't want this class to be stressful. I don't want to be stressed out. I don't want y'all to be stressed out. So let's look at this one, atomic number 8. So we're going to look at here 8. That's oxygen. Okay, so I'm going to type oxygen in here. And I think you got to spell it just right for it to turn green. So if you put a capital in there or any other weird things in there, then it won't match. So I just typed oxygen, all lowercase, no spaces, nothing else, and it turns green. Okay. Now, how many protons does oxygen have? Well, its atomic number is 8. So it has 8 protons. What is its mass number? Okay, this one's going to be a little weird to calculate, but the mass number, remember, is equal to protons plus neutrons. So in this example, protons is 8, neutrons is 8. So that's 8 plus 8, that's 16. Okay, so when you're doing this and you're calculating the mass number, you need to use the information from the table, this table that you're given, not the periodic table. You do not use the average atomic mass from the periodic table, right? If you look at your elements on here, you need to be using the number above the symbol. That's the atomic number. You need to use that. But do not use the number below it for this stuff, for this table. Ignore that number on the bottom, okay? Because that will not help you, okay? That'll make it more confusing, and you'll be getting some of these wrong, okay? So follow the table that you got here, okay? All right, let's see what else we got. So that was 16. So I'm going to type 16. Okay. Now, why are these not turning green? Oxygen is 8, isn't it? Atomic number 8. These are correct, but they're not turning green. I don't know why. Oh, because they were given to us. Okay. So the ones that we had blank and we typed them in, they turned green because we got them right. The other ones were given to us. So they're not going to change colors. They're already done for us. Now, number of electrons is going to be equal to the number of protons. So that will be 8. So we type enter. Okay. I'm going to go down and do this last one because this one looks a little challenging. We have the atomic number, It's 76. So let's look on our handy dandy periodic table and find 76. 76 is right here, and it's OS. So I'm going to write osmium. Let's see if I can spell that right. Osmium. All right, we got it spelled right. The atomic number is 76, and so the number of protons is 76. It has 114 neutrons. Okay, so that's what they told us. So what is the mass number? Well, it's going to be protons plus neutrons. 76 plus 114. What do we get? 190. Okay, so 190 is the number of neutrons. So remember, mass number equals protons plus neutrons. Okay, so let's see what we get. So 190. 190. There we go. All right, and the number of electrons will be equal to protons. It's going to be 76. Boom, we get all of our greens. All right, so finish filling in this table, and then scroll down. There's some questions down here. How are the atomic number and the number of protons related? I just talked about that. How do the number of protons, neutrons, and the mass number relate to each other? Well, we just said that the mass number is equal to protons plus neutrons. Okay, now these questions are fill in the blank, kind of short answer, and so it's not going to change colors on this part. So you'll just type your answer in, and it doesn't mean you got it wrong. It's just in the table. When it's like a number, those are set so that if you type in the correct number and the answer key that it's got, then it'll turn green. Okay. What is one thing that determines the identity of the element or the atom? Number of protons. Okay. What subatomic particles are equal to make a neutral atom? Protons equal electrons. If you got 3 protons, you got 3 electrons. Right? Explain in words how to calculate the mass of a sodium atom. Okay, so how would you calculate the mass of a sodium atom? You'd have to look in the periodic table. Sodium is right here. Element Na. Element number 11. Draw and label 3 element symbols that are representative of the periodic table. They should have an atomic number, mass number, name, and element. So you can just copy it from the periodic table, and here's an example. You just type it in, okay? And then when you're done, you're going to click share. It's going to be locked, so let me lock it back. So this is what you're going to see. It'll say restricted. Only people added can open this link. So if you change this to anyone with the link, or even just Garland ISD, change to Garland ISD, click copy link, click done, and then in this classwork, you're going to, let me do a few things here. Go back to the assignment, parts of the atom classwork. Where is it? Parts of the atom. Where's current assignments? Cycle 2. Here we go. Parts of the atom classwork. We go up here to click submit assignment, and in the text entry, we click copy paste, Control and V at the same time, Control and V, or right click with your mouse and go to paste, and then just click submit. Okay, and you'll turn that in. All right. So I wanted to go over how to do that. All right, let's go back. Let's go through our isotope notes, okay? So make sure you guys are answering the questions on the Ed puzzle and turning that in during class today. I'll drop something. Keep checking my periodic table. All right. This is the links for week 1. So if you're missing anything from week 1, here's the links. Here's week 2. Here's week 3. So on Friday, we did a practice quiz, and then on Friday, we did building the atom. So I'm calling those 2 part of week 3. And then today is day 6, so here's day 6 tasks, and then here's parts of the atom classwork. All right, so students are expected to complete the warm-up, the Ed puzzle, and the practice quiz during class. The warm-up's like 8 questions, it's not bad. The Ed puzzle will be 10 questions, not bad. And then the practice quiz is 15 questions. So that's totally doable. I know it may seem like a lot, but it's really not bad. And then the classwork will be due by next Tuesday, okay? Students will be able to understand the definition of an isotope. Students will be able to decipher or read and make sense of isotopic notation, calculate average atomic mass for an element. And that's going to be a little tricky, okay? All right, so here's the Edpuzzle assignment. Students need to watch the video and answer the 10 questions. I'm gonna make it just 10 questions, okay? Here's all of Unit 3. So far, we have covered this, and today is this. So we still have to talk about the history of the atom, which we'll do next week, arrangements of electrons, and nuclear chemistry. So we'll be getting to that. Okay, so here's a review from last time. The atom is made out of subatomic particles, the proton, the electron, and the neutron. Protons are positively charged. Proton, positive, they both start with P. They're located in the nucleus. They are the same as the atomic number. The atomic number is equal to the number of protons. The number of protons identifies the element. Hydrogen is element number 1 because it has 1 proton. Helium is element number 2 because it has 2 protons, and so on. Each element is defined by its number of protons, okay? If you add a proton to an atom, you get a different element, all right? The neutron has no charge. It's located in the nucleus, and that's easy to remember. Neutron, no charge. They both start with N. Neutron, no charge. They're located in the nucleus. They have mass. So protons and neutrons have mass, and when you add them together, you get the mass number of the atom, because all the mass in the atom comes from the protons and the neutrons. Electrons are negatively charged. They are located in these shells around the atom. They are not in the nucleus. They have no mass, and if you electrons contribute to the charge. So protons and electrons are doing a tug of war. Protons are positive, electrons are negative. And so if protons win, then the atom will become a positive ion. If electrons win, if you have more of them, then it'll be a negative ion. Okay? The nucleus is the center of the atom. It has protons and neutrons. It has all the mass, but none of the space. All right, and then the protons plus neutrons will give you the mass. Electrons are surrounding the nucleus at a great distance. They contain electrons. Electron cells contain electrons. They have a large volume in compared to the nucleus, but they have no mass. Okay, and we'll talk more about the electrons a little bit later in this unit. All right, here is our nuclear symbol. Okay. Looked like my internet dropped out or something. Okay, I'm still recording. Okay, I'll continue. Let me make sure I'm presenting. I'm confused. How many? I don't know what's going on here. Let's see. Somehow I lost my thing, and I can't tell if I'm presenting. Okay, so let's present now. Entire screen. Okay. That's interesting. Okay, so I went through all this stuff. Let's see if I'm presenting now. Okay, so we're back. Okay. So this is where we're at. So we're looking at the nuclear symbol. All right, so in the middle of the nuclear symbol, we're going to see the symbol for an element. Okay, so this is the way, this is our favorite way, our favorite way to represent elements, okay, in an atom. So if I were to pick up an atom, if I were to write down and describe what's in it, this is how I would do it. I would use this. So let's say we're talking about hydrogen. Well, then in the symbol in the middle, I would write the symbol for hydrogen. I would write H, okay? Because that's the symbol for hydrogen. And then in the bottom left, I would put its atomic number. So atomic number goes right there. That's the number of protons. Okay, hydrogen is element number 1, so it's got 1 proton. And then the mass number would go up here in the top left. So in this thing, A is equal to the mass number, and Z is equal to the atomic number. A and Z are just variables to represent something that would go in that space. Okay, so mass number goes up here, atomic number goes down here. That's all that's saying. So mass number is equal to protons plus neutrons. So let's say that we had a hydrogen atom with 1 proton and 1 neutron, total mass of 2. So I would put 2. And then my charge would be equal to 0. So usually there's not a charge. If there was a charge, let's say it was positive 1, then the charge would go in the top right corner. So charge would go right here. Okay, so that's where the charge would go. So let's rewrite that. 2, 1, H plus 1. So that would be a nuclear symbol for a hydrogen atom with 1 proton, 1 neutron, and actually it would have no electrons because it's got a positive 1 charge, which means it has 1 extra proton than electrons, right? Okay. And then this is the thing from the periodic table. If you look at iron, this is what you'll see. This is the atomic number here. That's the number of protons. And then the name of the element is down here. And then we have something below that called the average atomic mass. Okay, so now at this point, we want to talk about average atomic mass. Average atomic mass is the average mass of all of the atoms of that element. So the average atomic mass for iron is 55.843. Everybody see that? And we want to be able to get that off the periodic table. So if you look at your periodic table and find iron, you want to be able to get that value. Like what is the average atomic mass of iron? You look at it, you find that value. Okay? That value represents the average. It's a weighted average. And I'll talk about what that means in a little bit. But it's a weighted average of all of the types of iron. Okay? And it's a decimal number. Now, if we round that to a whole number, that will tell us the most abundant isotope. So 55.847, since it's a 0.8, that rounds up. Remember that anything above 5 rounds up. And so that's going to round that up to 56. So if I round 55.847 to a whole number, I get 56. And iron 56, if I write it like that, iron dash 56 or Fe dash 56, that would be the most abundant isotope of iron, the most abundant version of isotope. That means that if I pick up an iron atom somewhere on Earth, most likely, it's more likely that I'm going to have iron 56 than any other kind of iron. And that means it has a mass number of 56. So the mass number is 56. Okay? So that's iron with a dash and then 56 for the mass number. It's not a minus sign, and it's not telling me the number of protons. It's not telling me the atomic number. It's telling me the mass number. So it just takes some getting used to. Okay? All right, next one. Only got a couple slides here. Here's some examples here. So this is carbon 12. It's carbon, so it has an atomic number of 6. And then the mass number goes up here. Okay. Chlorine 35. The mass is right there, so that's chlorine 35. So that's what it looks like. It's got a total mass. It's 35. Protons plus neutrons. Okay. And then carbon 14, it's carbon, so it has atomic number 6, because carbon's atomic number, again, on the periodic table is 6. And then it has a mass of 14. Okay? The mass number is the number of protons plus neutrons. The atomic number is the number of protons. Okay? So this is what we call isotope notation. So we can write carbon 14, carbon dash 14, carbon being the element, and then 14 being the mass number. Or we could write C-14. Okay, and that represents that particular atom. 6 protons, 8 neutrons, and 6 electrons, no charge, right? So 6 protons, 6 electrons, and 8 neutrons. Where did I get the 8? Remember that neutrons is equal to mass number minus atomic number. So that is 14 minus 6, which gives us 8, right? Okay. All right, so here's some notes here. All right, here are 3 different versions of hydrogen. And I'm going to draw a picture of these. So this first hydrogen, I got 1 proton. I'm going to make this a proton. I'm going to fill it in now. So this is a proton. And then out here, we've got 1 electron. So 1 proton, 1 electron. That's what that would look like. No electrons. Actually, 1 electron. No neutrons. So 1 proton, no neutrons, and 1 electron. It has no charge. The mass number is equal to 1. Why is the mass only equal to 1? Because it only has 1 proton. And that's the only particle that has mass that it has. And it doesn't have any neutrons. So 1 proton, it's got a mass of 1. So then the total mass of this atom is 1. It has no neutrons. All right. Now the second one, same thing. It has 1 proton. Any atom that has 1 proton is defined as hydrogen because hydrogen is element number 1 on the periodic table. Okay, but this atom of hydrogen will have a neutron in there as well. Okay, so 1 proton, 1 neutron, and then out here in the electron ring will be 1 electron. So this version of hydrogen, this isotope of hydrogen, will have 1 proton, 1 neutron, and 1 electron. The charge will still be 0. And the mass number will be the number of protons plus neutrons. It has 1 proton, it has 1 neutron, so that'll be a mass of 2, which is why it's got a 2 there. And let's write the isotope symbols for these 2 as well. This first one is H-1. This is H-2, or hydrogen-1, hydrogen-2. Okay, now let's look at hydrogen-3. Hydrogen-3 would look like this. 1 proton, 2 neutrons, all in the nucleus, and then it's got 1 electron out here. So 1 proton, 2 neutrons, 1 electron. Mass number is 3, protons plus neutrons. 1 proton and 2 neutrons makes 3, and the charge is still 0. All right, so that's the mass number 3, hydrogen-3. So these are 3 versions of hydrogen that have a different number of neutrons. When you have an element or an atom that has a different number of neutrons, those are called isotopes. Extra or fewer neutrons. Okay, another example, oxygen. There's oxygen 16, there's oxygen 17, there's oxygen 18. What do they have in common? They're oxygen. So they have 8 protons. What do they have that's different? Number of neutrons. Oxygen 16 has 8 neutrons. Oxygen 17 has 9 neutrons. So this guy has 8, this guy has 9, this guy has 10. So the number of neutrons is changing. All right, how do we calculate the average atomic mass on the periodic table? So where did the numbers on the periodic table come from? The bottom numbers. It's a weighted average of all the known isotopes. So if I take these 3 versions of oxygen and I take an average of those, it's not just a regular average, right? You guys know like normal average. If you had like 3 grades, let's say you had 3 tests for 6 weeks, and let's say you made 100 on one, 100 on the second, and 100 on the third. Well, the way that you would get the average is add all of them up and then divide by 3. That's a normal average. That means they have equal weight. This is average atomic mass is not an equal weight average. It's a weighted average, meaning that the isotopes that are more common, more abundant, have more effect on the average. Okay. So if these 3 are the isotopes of oxygen, what we do is we do a weighted average, and I'll show you how to calculate in a second. And what we end up with is a average mass of 15.999. Okay, so how do we calculate that? We multiply the percent abundance by its mass. Okay, but we need to use the decimal when it's given. Okay, and then we're going to add them all together and then divide by 100. Okay, so that's the process of doing these problems, like described. All right, we're going to multiply the percent abundance for each isotope by its mass, and then we're going to add them all up and then divide by 100. Okay, so let's do an example. Rubidium is a soft silvery white metal that is very reactive to water. You take rubidium, you put it in water, it explodes. All right. It also has two common isotopes, rubidium 85 and rubidium 87. So rubidium 85, that's rubidium with a mass of 85, and then rubidium 87. Two versions of the same element with a different number of neutrons. If the abundance of rubidium 85 is 72.2% and the abundance of rubidium 87 is 27.8%, what is the average between the two? So we take the percent abundance, how common it is, and we multiply that by its mass, and then we add it up. So that's what we mean by a weighted average. That means that since more of this isotope is rubidium 85, the weight of that isotope, 85, will make the average closer to 85. And actually, if you look at the average atomic mass of rubidium, it's 85.5. It's just a little bit more than 85, right? And so the average is closer to 85 because it's more common. So the average of all rubidium in the universe will be closer to 85. All right, so let's see how we calculate that. And then we'll wrap this up. Oh, okay. So where'd my example go? Here we go. All right, so here's the question again. Did something wrong here. Here we go. So here's our example. If the abundance of 85 is 72.2% and the abundance of rubidium 87 is 27.8%, what are we going to do? We're going to take the 72.2% and multiply it by the 85. Take the percent abundance and multiply by its mass. This is a percent abundance. This is its mass, 85. Multiply those together, you get 6137. Do the same for the other isotope, 27.8 times 87. What do you get? 2418.6. And then you add these two up. That plus that gives me this. When you get your final weighted average, you need to divide it by 100. So we take the percent abundance of each isotope times its mass, add them up, we get a number, divide that by 100. And then this is what we get. That's our answer, 85.556. Okay? Okay, and then the unit here is going to be AMU or grams, depending on what's given in the problem, and I'm not worried about the units. The most common unit that we use here is called AMU, which is atomic mass unit. The atomic mass unit of a proton is 1. Neutron is 1, and the electrons have no mass, so it's 0. Okay, so let's go back and look at some examples here. Okay, so average atomic mass is the weighted average based on isotopic composition. Here's our formula. Percent isotope A times the mass of A plus the percent of isotope B times the mass of B. And you continue to add until you run out of isotopes. Okay, so that last example, we did this twice because we had 2 isotopes. But if we had 3 isotopes, we would do it 3 times. You would take percent, well, you can't see what I'm writing because it's black. So percent A times the mass of A, add that to the percent B times the mass of B, plus the percent C times the mass of C, and then add all those up. And that'll give you the mass number in AMU. Okay? And we'll practice this. All right, so what is the average for lithium? Okay. We take 7.42%, which is right here, and it's lithium 6, which has this mass. So we're going to multiply by 6.015. That's the percent abundance times the mass. We're going to add that to the other isotope, which is 92.58 times its mass, which is 7.016. So percent abundance times the mass. We do these two numbers multiplied together. What do we get when we do that? Let's try that. 7.42 times 6.015. I get 44.6313. And then I'm going to multiply these two together. See what I get. 92.58 times 7.016. I get 649.54. I add those two up. What do I get? 694. So I'm going to write it up here, guys. Why can't we see what I'm doing? 694. And then we divide that by 100. 6.94. So our answer here, I have to erase because I have no room. I was trying to write at the bottom and it wouldn't let me. What's wrong with my eraser? There we go. Come on. There we go. So we had 694. We divided by 100. We get 6.94. And then our unit will be AMU. That's the average for lithium. And you can always check your answer. Because if you look on the periodic table, lithium's right there. And its average atomic mass is at the bottom of the, below the symbol. And so it says 6.9. That's close to what we got. So you can always check your answer that way. Okay. Let's see what else I got. I think that's all I got, guys. All right. Have a good one. Thank you so much.